Hello, welcome to this new YouTube channel. I'm Lorenzo Foti, based in Italy. I'm one of the Excel Sports player that compete in the Excel Sports World Championship this year, actually. The purpose of this channel is to share my journey of training into this new competition, which is organized by the FMWC, takes place online, and this year with the finals be hosted in Las Vegas. And basically requires the players to solve these games that I'm going to show you in a while. And with this training journey, I want to share my training across these cases, which I collected over the past weeks to prepare myself for the competition. Let's dive right into it. This one in particular is being produced by the South African Excel Championship, which is a local chapter of the bigger World Championship. Uh, as you can see, those cases are based on fun games usually. In this case, it will be a card game. It is called Clock Solitaire. The case is designed by Jason Weber, which is one of the regular competitors in this competition. The format is pretty standard, so as you can see, there is a quick brief that give you the instructions of the game in order to be able to solve it. Usually 5 levels with one question each of increase in difficulty, starting from a fairly easy one up to the harder questions in the end. Each level includes datasets that need to be solved. So each game includes, for example, 10, 20 games with the datasets provided, and you need to provide an answer. Basically, the more correct answers you provide, the higher you will score. And usually the time allocation for the entire game is 30 minutes. On top of that, there are usually 3 bonus questions that give you extra points on top of the usual 1000 points available for the standard questions. During the online competition, because you have also the streaming of the online competitions of these battles, the first player solving the bonus question gets the point. In the offline competition, you just need to solve them and you will be awarded the points as well. Okay, let's dive into the case. So let's see what the rules are about for this particular one. So this is a luck-based card game played by one person. Okay, standard deck of 52 playing cards. Setting up the game, the cards are shuffled into random order. Okay, and then they basically dealt in a clockwise fashion, 2, 3, 4, up to the queen and the king in the middle. Okay, and then you start again for the ace in the first position. This means that the last 13 cards dealt will be the cards on top of each of their respective piles, the very last card dealt being the card on top of the K position. Okay, this creates 12 piles of random cards lying face down a clock pattern. Okay, so 13, 13, 13, 13. Okay. Play begins by turning over the card on top of the K position. It has the last card that was initially dealt. When a card is revealed, it is placed face up under the pile and the corresponding number. Okay. And the top card of the pile of that hour is then turned over. If the king is revealed, it is placed face under the pile in the middle. Okay, so basically flip the card on top of the K pile. You see which card it is. For example, if it is a 6, you go into the 6 pile, you flip the card in the 6, you see what card is it, and you go over and over again. This pattern, okay, and then turning over continues until all 4 kings have been revealed. The game always ends after the 4th king has been turned over. If all the other cards have been turned over when the 4th king is revealed, the player wins. If there are system cards left unturned when the 4th king is revealed, the player loses. Okay. Okay, I think I have it. Let's see what we have for the questions. Level 1. When setting up the game, what is the last card placed in the king pile and consequently the first card played as the game commences? Okay, I think this is a fairly easy one. You also have an example for each level that says the correct answer is the 6 of spades, which actually is the last card because we said that you go over the clock to distribute the cards. So basically, the last set of 13 cards will be the cards on top of each pile, and in particular, the king will be the last card dealt. So the six of spades is the correct answer. There are multiple ways to solve this easy level. Basically, you just need to pick the last card here in this list of cards. What I usually do to solve this case is to prepare a solver worksheet in which I basically try to solve the case and then scale the solution using a technique that I will show you in a minute. So we have example one, and then I'm going to XLOOKUP the cards. So basically this gives you this list of cards that now are under example one. If I want to scale this to other levels, I just simply going to change this. Okay. A good way to manage this is to text split, which is a modern array formula used to split the cards and then transposing it to make an array in the vertical direction. And basically, this is fairly easy because the solution is just to take the last card of this array, which is the six of spades. I'm going to have a list of all the levels available for this game. I'm going to build a data table, which is basically says pick this six of spades and then replicate the formula, the logic of this formula, which is actually equal to this last row, but then cascades back with all the formula that I've built to solve this level, and apply this by changing this example one, first of all with one, then with two, then with three, and so on. So basically those are our answers for level one. I'm going to paste them here. It says 599, and we can double check that this is correct. Okay, so moving on level two. When setting up the game, what is the first card placed in the king pile? Okay, so they're basically asking me to find the first card going into the king pile. Should be the 13th card of the array, actually. So let's see if this is working. Example 2, card number 13 will actually be this one. So the 9 of diamond. Okay, it's actually not correct. Probably I miscounted. Yeah, it's the 2 of diamond actually. So I could just make this actually to solve the level. They're asking for games 11 to 20. I've already set up the data table, so this should be fine. Let's see if this works. 549 and okay, checks out. What's the second card picked up? It has after picking up the first card from the top of the king pile, what is the next card to be picked up? So, okay, here is asking to perform a first iteration of the game, actually applying the game logic. So I will need something more, little bit more complex to solve this. Actually, what we are saying is that we have the position of this card, which is 1 to 13, and then you start over from position 1 when you have finished a first distribution of the card. So I'm going to write if this plus 1 equals 14, 1, otherwise this plus 1. So this allows me to go back to 1 when I reach 13. Okay, as you can see, the 2 of diamond, which was example 2 solution, is exactly the first time I encountered 13 in the iteration around the clock. As the cards uh, go on top of each other, basically I will have 4 rounds of distribution. So basically those first 13 cards will be in fourth position, starting from up, going down. Then I will have 3, then I will have 2, and then I will have 1. Okay. So what is now asking is to perform a first iteration. So we know that the first card being revealed is actually the top card in the K bucket, if I remember right. So yes, which basically is always this one. So we know that the Jack of clubs is the first card to be revealed. Now, what we are going to do, we're going to say, okay, Jack of clubs, we know that Jack goes into position number 11, which is 10 plus 1. And so we'll need to go into number 11 here, flip the card and see what it is, and go over and over again. Let's just confirm that the logic is correct, because example 3 says that the answer is Queen of Hearts. So 8 of clubs, position number 8, okay, Queen of Hearts. As you can see, I might also solve this manually, but it's actually not the purpose of this competition, because you need to be very, very fast in order to perform this kind of solutions. So what I usually do is to separate the number and the kind of cards, so the clubs, hearts, and so on. Can leverage the fact that the seed of the card is always one character long. So I'm going to, sorry, write this of one, always gives me the kind of card, and then I'm going to substitute this, this, and nothing, and this gives me the face value of the card. I cannot do left of this because there might be cases in which the face value is 2 digits long, for example, the 10, so this will result in a not correct solution. Okay, so we know that the next position I will need to flip is position number 8. I want to do this a little bit more dynamically, so what I'm going to do is let's put in the 13 position available, and let's say that this is ace, then 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I have jack, jack, queen, and king. Uh, I'm going to call those positions, I'm going to call those cards. Yes, I'm going to call this the deck, and that's pretty much it. Uh, I also need to say that when I'm going to flip, I'm going to flip progressively for each position, starting from 1, then 2, then 3. For example, if I need to flip position 8, I need to know whether this is the first time I flip that position 8 or this is a second, third, or fourth time. So let's say that we always start with 1. Uh, and then, sorry, let's say that first of all, this is an X lookup in cards, and I want to have the position as an output. Okay, this is giving me error because we are mixing up numbers and strings. So what I usually do is always convert everything to string, and this is working fine. So we know that 8 is in position 8. Okay, that was easy, but for example, this would have been a jack, it would have given me 11. Uh, okay, so let's assume this is the first time I do this trick. What I need to do is to pull out the card which is in position number 8 and in the pile position first. So one function which might be useful to leverage is filter. So I want to filter this because it allows me to apply a double condition. I want to filter the deck when the position lock is actually 8 times. So this is the way to apply multiple conditions at the same time. So this is an AND application of the conditions. I want this lock to be 1. Okay, and this gives me the Queen of Hearts. So, and just to do this, 21 to 40, copy, paste, voila. 1271. Okay, there is actually an error here. 1, 2, 3, 2. Let's see why actually. So going to paste this here. Check. Okay, this is one error, for example. So data set 27. Okay, so I'm flipping the cake and it's the third position. Ah, okay, I got it. Basically, if you since you go straight into the K, you always start with this card already being clear. So if you flip a K, for example, starting from the K position, the next one you will need to flip is the second one. So it will be a King of Diamonds. So basically, we need to say that this is 1 plus if this equals k, 1, otherwise 0. Okay, so I'm flipping card in 13 position 2, which is a jack of clubs, which I think is correct. Let's see if now this is working. Copy and paste values. Okay, 1, 2, 3, 2. Okay, so this was just one iteration. Now the game is asking to perform 10 iterations, but basically the solution is always the same. So what I can do is to leverage the same approach. So I'm going to say that I start over with this one. I can copy this down. I can copy this down. I can copy this down. I think I can copy this down. No, I actually need to make sure that this is the this is whether these have been flipped already in the previous one. So I'm going to add a count ifs of this. Sorry, not before the range. So this I will lock the row equals this. Okay. So what I am saying is if I already flipped a jack and another jack is going to be flipped, I want this to be position 2. If already, so 1 plus 2. If I already flipped 2 jacks, I want this to be 3. So 1 plus the 2 jacks I've already flipped. So let's copy this down. You can see that the formula is dragging towards the bottom of the table. Uh, I'm probably going to need up to 52 iterations of this. Okay, let's see if this is working. Example 4 says the 10th card to be picked up. So this is first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10, 8 of clubs. Yes, 8 of clubs. And actually, for example, here we have a 2. So this means that the 2 of spades is the second 2 to be flipped. So I'm going to flip position 2 into the pile. Yes, that's correct. So I'm going to just say this requires 41 to 70. Let's copy this. Let's copy the values here. And it says 1892 is actually 1892. Okay. So last level says on what turn does the game end? It asks when is the final king played. Okay. So example 5. I think this might be as simple as saying if or this equals, sorry, nothing, not require an or, equal k, say 1 equals 0. Okay, and then I'm just going to add up all the kings that I've found, and then I'm going to say, I need some more space, match 4, which is the fourth king revealed, here, exact match. Uh, nope, actually, the range is this one. Okay, so it says that the first occurrence of 4 is in 13th position, which is actually the answer for our level. So I'm going to change this one to this, and it requires games 71 to 100. It says 203471, and that's correct. Okay, so we've solved the base questions for the game. Let's go into the bonus questions. So the first one says, after setting up the game 50, what card was on the top of the queen pile? Show number and suit. I think this is quite easy. Consider the model we already built. So game 50, the first on top of the queen pile, queen is 11, 12 position. So it will be basically this, 8 of clubs. Okay. Let's check whether this is correct or not. Yeah. Then, after setting up all the games, excluding examples, how many red cards, hearts, and diamonds were on the tops of each of the piles? Okay, so they're basically asking how many hearts and diamonds we have on top of each of the piles for all the games. Again, I can leverage the data table to solve this quickly. Basically, we're saying that the top of the table is actually this set of 13 cards. I will need uh, I will need to pull out from here the seed of the cards. So this is a right, this of one. Okay, I will need the red ones. So basically, those are the ones that I will need. Let's call those red cards. And I'm going to say if or is equal red cards. Give me one, divide 0. Okay, so we're saying that here we have 10 red cards in the first, on the cards in the top position of each pile. So I'm going to just add the sum of this. Okay, and then I'm afraid I will need to build again my data table, which is this, by changing this one. Okay, each of the games excluding examples, the sum is 651 without the initial one, 651, 651, and 651. Okay, last, what is the average number of cards played before a random game of clock solitaire ends? Round it to the nearest whole number. Try simulating the outcome of 100,000 random games. Okay. This will imply probably a bit of simulation. Let's see if we are lucky enough to get this through the 100 solutions we have computed for the purpose of this game. Average number of cards played before a random game of clock solitaire ends. So basically, is exactly this, I think. If I just average those, I get 41.73, which is 42, rounded to the nearest integer. 42, and that's actually 42. Maybe we have been lucky. Okay, that's pretty much it for today. I think this was a very nice game. So congrats to Jason to have designed such a nice game. This actually has been provided as one of the final games in the South African competition that I think was held beginning of September in Johannesburg, I think. So that's it, and I will see you in the next video. Bye.